Physics test today.
Really was gone. Rah, rah, Rasputin, Russia's greatest love machine. It was a shame how we carried on.
A few moments later.
Will Smith from Wild Wild West? Thank Josh you're here, Will Smith from Wild Wild West. I need help on my physics test, and it's due today.
Walk with me. Physics!
Please teach me about physics.
Well, little boy, it all starts with magnets and electricity. So I guess the best place to start is magnetic domains.
Oh boy, those do sound pretty neat.
Well, Asa, everything around us is made of atoms. And atoms have electrons, which is electricity. Electrons act as little magnets because they have poles and charges.
Hey, Will Smith, can I drive?
No! Ugh.
So does this have magnets in it because it has electrons in it?
No!
Whoa.
Whoa. Whoa.
That was weird.
Yeah.
You're gonna need to teach me a little bit more about magnets now. No more teleporting me, alright?
I'm gonna teleport you one more time.
Why am I in different clothes?
You don't need to worry about that. Now, let's get back to magnetics.
When we were talking like back there, you said that everything's made out of electrons, and electrons are like small magnets. So does that mean everything is magnetic?
Well, everything has electrons in it, but usually these electrons are oriented in different directions, so they basically cancel each other out. But when all of them get oriented in the same direction, it becomes susceptible to magnets, and this is known as a magnetic domain.
So Will Smith, what do magnetic field lines look like in bar magnets?
So this is a bar magnet with all of the electrons oriented the same direction. So the magnetic fields come out the north end and then get pulled back into the south end, or the negative end.
So can I just like connect any side of a magnet to another side of a magnet?
No. So as you can see here, like poles repel one another, but unlike poles attract. So as you can see, the same poles repel, but opposites attract.
So I heard something about ferromagnets. What's up with that?
So ferromagnets are pretty cool. They can be made out of few metals like nickel and iron.
Like the nickel in my pocket?
Well, that's not actually nickel. So anyway, where were we? Ferromagnets. So ferromagnets can actually spin and change their orientation when exposed to another magnet. And if that external force is powerful enough, it can permanently change the magnet's orientation.
Now we have come to solenoids and electromagnetic fields.
Oh boy, solenoids. That sounds K-Razi. What's that, Will Smith from Wild Wild West?
A solenoid. They're pretty simple.
Well, that's kind of cool. I mean, it's whatever, man.
Now with less coils, it doesn't work as well. That's Faraday's law.
What if we only use one battery?
That's a magnet, idiot.
Well, with only one battery, it doesn't work quite as well.
Well, the more batteries, the more powerful the field.
What happens if you use a different material from iron?
You see, iron is the most commonly used material for solenoids, but other metals and alloys can be used.
Holy moly, like ferronickel?
Gee willikers, that is a material that is commonly used in solenoids, but the best material is 100% pure iron.
So Asa, this is an electric generator. What happens is this little wind turbine, it spins. And this copper wire spins inside this permanent magnet, which is right here, which creates electric current, which then powers the bulb.
Will, what happened to you?
Never mind that. Next we got transformers.
I love Transformers. Bumblebee is my favorite.
Not that kind of transformers. Idiot!
I'd rather talk about the other ones.
Transformers are actually electrical devices that transfer electrical current between electrical devices.
Don't you mean that transformers are electrical devices that transfer electrical energy between circuits?
Yeah, transformers are used to step up and step down voltages.
Can I see an example, please?
So electrical current goes through here, through the hollow core and secondary winding, and then it comes out at a different voltage level.
So that means they're 100% efficient, right?
Unfortunately, they're only about 99% efficient because of resistance from the secondary winding.
And magnetic effects.
You got it, buckaroo!
School's over, idiot. You missed the test.
Wait, what?
You heard me, maggot. You missed the test.
Oh.